All right, so for 10.6, we're just going to go through one page, page 314 in your notes packet. We're going to do a word problem for polynomial functions. Okay, so this is a lumber problem. Woody Forester has the job of figuring out how much lumber can be obtained from different sized trees. From sawmill records, he finds the following numbers of board feet of lumber that can be cut from trees of given diameters. So if a tree is kind of a skinny tree with a 1 foot diameter, you can get 10 board feet of lumber. And board feet is a cubic measure. Okay, so it's 10 cubic feet of lumber that you can get out of this tree. Now, if it's a bigger tree, 2 feet in diameter, you can get 99 cubic feet, board feet of lumber, and so on. So if you've got a diameter of 4 feet, that's a much bigger tree, and you can get a heck of a lot more lumber. Okay, so he figures that since it's a cubic measure, a cubic function would be reasonable. Okay, now we're going to go to the calculator. I'm going to show you a really cool thing that you can do this on your calculator. We're going to do a regression. Okay, some of these instructions we're not going to use. I'll show you another way to do it, and I'll fill that in. Okay, so take out your calculators. What you're going to do is you're going to go to your home screen. You're going to do a new page. We're going to do lists and spreadsheets. So this is correct. We're going to go on lists and spreadsheets application, add lists and spreadsheets. Okay, when you get to this screen up here, you're going to type in our x variable, which is going to be diameter of feet. Okay, so let's just type in diameter of the tree. And then in column B, we're going to put board feet. You could abbreviate if you want. I know that's kind of clunky to type in on your calculator. Oh, it doesn't like that. Okay, so you can't do, we'll just do board feet. Okay, now this equal row, you're never typing anything in this row up here where it says equal, because that's where you would, on another occasion, you might put formulas in there. It treats those as numbers, numerical values that are going to be used in your calculation. So you don't want to put anything in there. This, the A and the B columns, the top column, that's just to type in descriptions or names of your columns. Okay, and we're going to put in our data 1, 2, 3, 4. In column 2, we've got 10, 89, 324, and 745. Okay. Go back to our paper for a second. Okay, so we've typed those in there. Okay. Column A, we typed in the word feet or board feet. Column B, I typed in diameter just because I don't want to get feet and board feet mixed up. Let's type in diameter. And then in column B, we did board feet. Find the particular equation expressing board feet in terms of diameter. Remember, whenever it's worded there that way and you've got a function or an equation expressing, it's always y in terms of x. Okay, so let's make sure we did that right. So the y has to be the board feet, which we did. This is our y value. And the x is the diameter. Okay, I always like to define our variables. So x is your diameter of the tree in feet, and y is the amount of lumber, the lumber obtained from the tree, lumber obtained in board feet. It's always useful to write those out in pretty good descriptions of those, because you may refer back to those. Okay, find the particular equation expressing board feet in terms of diameter. We're not going to do that. What we're going to do is you're going to add a page. I'm just going to add a calculator page to your document. And this is, you do Control plus, CTRL, and then the plus button. That adds a page. And then what you're going to do is menu, statistics. Let's take a look. I think it's, so we're going to add a page, Control plus page. It's right there. So Control Doc. That adds a page. We'll add a calculator page. And we want to do menu, statistics, number 6. And then we do its stat calculations, number 1. And then we go down to cubic regression. Okay. So let's go back there and write this in our notes. So we did menu, statistics, then I think it was number 1, stat calculations. And then we did cubic regression. Okay. And this right here was control, and it was plus page, but it was control doc. The control button and then the doc button. Behind there in blue, it said plus page, and that's how you add a page. Okay, so now we're going menu, statistics, stat calculations, cubic regression, and I'll show you how to fill that out. The X list, remember how we defined our X variable. Now this gets populated with whatever we name those columns. And the diameter was our X variable, and our Y variable was board feet, the amount of lumber obtained. Okay, we're going to save our regression equation to F1. Leave that alone. That way, if we add a graph, our equation's already going to be populated in the graph. Okay, you can leave everything else blank, hit OK, and look at what it did. It came up with our cubic equation. It came up with the regression. It took those data points, and it found the cubic equation. We told it to give us a cubic equation that best fits those points. So that's in the form of ax cubed plus bx squared plus cx plus d. That's your standard form for a cubic function, cubic polynomial function. Now it gives us the a value, the b value, the c, and the d. So we're going to plug in 10 for a, 8 for b, -5 for c, and 1 for d. So our cubic equation is y equals 10x cubed plus 8x squared plus -5x plus -3. Okay, maybe I said 1. That's something else. The d is -3. Okay, so let's write this out. We can write out our equation on our piece of paper. Y equals 10x cubed plus 8x squared minus 5x minus 3. Okay. So right here is our equation. Find your particular equation. And we told it to put this equation into F1 of x in our calculator. Okay. Now we've got some questions down here. How much lumber can be obtained from a tree with a 5-foot in diameter trunk? Okay. So we're not going to do all this. Attica, okay, we're not going to do all that. That looks a little bit too complicated. All we need to do is go to our function and press our input and our output. We want F1 of 5. When our input is 5, okay, we're going to get rid of all that. We're just going to do this much simpler. Okay, so let's go back to our calculator. Watch what it did. Now let's add another page. So Control Doc. So add another page. We're going to add a graphing page. Now notice up here, if we arrow up, we've already got this populated in here. Now it had sometimes the calculator does that. That A value should just be 10. It's fine to leave it that way. The B value is 8. Sometimes it's just a little bit off the way that the calculator works. And then the C was -5. The D value is -3. Okay, let's hit enter to graph that thing. We can see it's a cubic equation. Okay, if we want, we can move this out of the way. Let's move that out of the way. And it's kind of nice to see all this. But this doesn't really capture the domain of our function in context. If we look at these values, we want x values from 1 to 4. We want y values from 10 to 745. So let's change our window so we can kind of see a better window. And we want to find the y value when x is 5. Okay. So let's do, well, you could just do a menu 5 trace, graph trace, and plug in a value of 5, hit enter, And it's going to give us our value of 1422. Now, it had changed our window, but what we can see here is f1 of 5 is equal to 1422. Okay, so you can see this point on our graph is the point 5, comma 1422. So when we have a diameter of 5 feet, we're going to get 1422 cubic feet of lumber. Okay, we simply plugged in 5 as our input, our x value, the diameter of the tree, into our function, and our y value is the amount of lumber. Okay. What defines the function? In part A has one integer 0. What is that 0? Find all other zeros. What calculator feature did you use to find the zeros? Okay, let's find our zeros. Let's go back to our page. And don't worry, hold on to that thought where I said we're going to change the window to where it makes more sense. Okay. Let's do maybe what we can do. Do you ever know this? You could do a Control Z and it undoes your last function. Control Z, does that work? Control Z. Oh, that didn't work. Okay. Well, what it did is it got rid of this for us. So let's add that again. Sometimes Control Z works. Depends what your last function was. But we still have this in here. Let's find our integer 0. It looks like there are 3 zeros. I'm actually going to zoom in a little bit. Let's go to Menu, Window Settings. I'm just going to go from X. I'm going to just -5 to +5. I want to see those zeros a little better, so I can see them a little bit better here. Okay. Now let's do finding zeros. You do Menu, you do Analyze Graph. Find your zeros is number 1. So remember, it asks you for left bound. Hit Enter. A right bound, hit enter. It's not going to find, oh, okay, it'll find all 3. This first one was -1, comma 0. That looks like that's our integer 0. Okay. The other 2 looked like they were, let's do Menu, Analyze Graph, 0. Now we've got to find this one here. So we go to the left. Notice on the bottom it's asking for a lower bound. Hit enter, go to the right, and it gives us this one. That's not an integer 0. Okay, that's the second one. Let's find the third one. Menu, Analyze Graph, 0. Let's find this one here. Go to the left, hit enter, go to the right. Okay, that one's not an integer 0. So our one integer 0 is -1, comma 0. Okay, one integer 0. What is that 0? It is -1, comma 0. Find all other zeros. Okay. So we can find the other zeros with the calculator, but look at what we can do. I think what we would rather do is use our other methods, and we can find the exact values of those zeros. Okay, so we're going to take this function right here, and I'm going to divide by -1 is a 0. We're going to divide by x plus 1. Okay, so we've got 10, 8, -5, -3. Our 0 is -1. Bring down the 10, multiply by -1. Add, multiply, add, multiply, and we get 0. Okay, so dividing this polynomial by x plus 1, we get 10x squared minus 2x minus 3. Setting that equal to 0, we can find our other zeros, which are going to be x equals opposite of b plus or minus square root b squared minus 4 times 10 times 3. 4 times 10 times -3, so it's going to be plus 120 all over 2a, so over 20. So I'm going to get x equals 2 plus or minus square root of 124 over 20. Let's simplify that. 2 plus or minus. I know that 4 goes into that. So that's 4 times 25. Let's see. $31. Okay, so 2 red 31. over 20, or I'll get 1 plus or minus rad 31 over 10. Okay, so there's our zeros. We can double check in the calculator that those zeros match the zeros we got on the calculator. Let's just check one of them. Okay, I'm going to use this calculator here. I've got 1. Let's do plus rad 31 divide by 10. Let's make that a decimal. So that's 0.6567. Let's just make sure that matches what we got on your calculator. Yep. And then if we did this one, we put a minus in front of the rad 31. That would be our other one. That would be negative 0.456. So we confirm that is our other one, negative 0.456. Okay. Draw the graph of this function. Now, this is a little goofy. I'm going to draw it twice. I'm going to draw this right here, where we can see the zeros. We can see the shape of the graph. And our looking at our equation right here, the y-intercept is going to be negative 3. So we've got a y-x-intercept of negative 1, negative 0.5, negative 3. It's our y-intercept, and then 0.67 was over here. So we get a function that kind of looks like this. And that's great. That's our function that looks like the calculator. That's not super useful in the context of this problem. Okay. Oh, that should have been point. Let's fix this. That was about 0.6, so that should have come up a little bit quicker. That's going to be key. So 1 was over here. This was the value of 0.6568. Okay. Now let's actually make a window that makes more sense in the context of the problem. So we want x to go from 1 to 4, maybe a little bigger, maybe from 0 to 5. Okay. 10 to 745, so maybe up to 1,000, maybe 1,500. So let's go to the calculator. Let's change the window so it makes more sense in the context of this problem. I'm going to go negative 1 up to, let's say, 5. My y, we're going to go up to about, let's say, 1,200. So I'll start at maybe negative 100 up to 1,200. Notice I've been putting 1,200. The reason I'm putting a negative value in there is so I can see my x-axis, and up here I can see my y-axis in my graph. I want to be able to see those. So this is going to make a little bit more sense. Okay, so if you did a menu trace, menu 5.1, you can see your values. When x is 1, we got 10. Okay, that was one of our points. When x was 2, we've got 99. When x was 3, got 324. Now our 0 when x was, what was it, 0.6568. We should be pretty close to 0, okay, because that was our 0. So this graph kind of makes a little more sense in the context of our problem. Okay. Now it's hard to see when we draw this on the graph. Here we do want to see the zeros, that's important, but for the context of our problem, our graph kind of looks like this. It's actually dipping down. It's going to go like this. And it dips here. It's going to go like that. Okay. The reason I did that because we want to see values of our function. We have 1, 2, 3, 4, and at 4 we were at 745. So that would make 500s about here, thousands up here. Okay, our X value is diameter in feet. My Y value is the lumber in board feet. Okay, what diameter of trees will produce 500 board feet of lumber? Okay, you could do this. I think it's easier to do than the graph. Let's graph the line Y equals 500 and see where that goes. Okay, so let's go to our graph. I'm going to go to, first I'm going to escape out of graph trace. I'm going to hit tab, and I'm going to graph Y equals 500. Find the intersection, that's menu. Do geometry, points and lines. Find your intersection points. We want to find the intersection between this graph and this graph. And there's our intersection. Okay, so it looks like 3.485 is the X value that gives you a Y value of 500. So 3.485 feet is your X value. Okay, according to this mathematical model, what is the smallest diameter tree that will produce any usable lumber? Okay, so this graph right here is not as useful for that. This one's useful. Think about your domain of this function. Okay, can your Y value, can your amount of board lumber be negative? It really can't. Can your diameter of your tree be negative? The only part of this graph that really is of any use to us is when X is bigger than this X-intercept right there. So we could say our domain is just when X is 0.6568 and above. So the smallest diameter of tree, well, the X has to be at least 0.6568 feet in diameter before we start getting a positive amount of lumber. Okay, so if your diameter of your tree is half a foot or 0.5, you get no usable lumber. Okay, the smallest tree that gives you any, that gives you even a positive amount, is going to be this right here. So it has to be bigger than this. All right, that's all for this question. I hope you enjoyed what we saw that the calculator can do for us, and enjoy the rest of your day. I will see you all soon.